All right, strap in everyone, because today we're taking a deep dive into something that might just make your head spin. We're going to be talking about logic, geometry, and a claim that seems, well, impossible.
Yeah, it's a real head scratcher. It's one of those things that makes you question everything you thought you knew.
We're talking about the equinoxes, those 2 days a year when day and night are equal all over the planet.
Mm-hmm.
Seems pretty straightforward, right?
Yeah, you'd think so.
Well, the source material we're looking at today presents an argument, a logical argument, claiming that on the equinoxes, the Earth's axis of rotation must be perpendicular to the plane of the ecliptic.
Hmm,
That's the path the Earth takes around the sun.
right.
Now, I don't know about you, but that sounds kind of crazy to me. I mean, we know the Earth's axis is tilted at about 23.5 degrees. That's what gives us our seasons, right?
Right. It's pretty basic stuff.
So how can this argument even begin to make sense? It's like saying up is down or black is white.
Well, the argument doesn't actually deny the Earth's tilt. It's more about how the geometry of the Earth, the sun, and the solar terminator, that line dividing day and night, all come together on those specific days.
On the equinoxes.
Yeah.
Okay, you're going to have to walk me through this one. Break down this geometric puzzle for me.
Oh, right. Let's start with the equinoxes themselves. On these days, the sun is positioned directly over the equator. Imagine a beam of light shining straight down on the equator at noon.
Okay, I can picture that.
Yeah.
The sun's not favoring the northern or southern hemisphere. It's hitting the Earth right in the middle.
Exactly. And because of that alignment, the solar terminator, that line between day and night, cuts the Earth at a perfect 90-degree angle to the equator.
Okay, so far so good. The terminator is perpendicular to the equator, but how does the Earth's axis fit into all of this? I'm still not seeing it.
Well, the argument also points out that the solar terminator is always parallel to the meridians, those lines of longitude running from pole to pole.
Right, like slices of an orange,
Yeah.
all meeting at the top and bottom.
Perfect analogy. Now, here's where the geometry gets interesting. The equator is perpendicular to those meridian lines, right? It circles the Earth at a 90-degree angle to them.
Yeah, that makes sense.
And here's another key point. The equator is also perpendicular to the Earth's axis of rotation. I mean, think about it. The axis goes through the north and south poles, while the equator circles the Earth's middle.
Okay, I'm seeing a lot of perpendicular lines here. I'm starting to feel a geometry proof coming on.
That's exactly where this argument is going.
Yeah.
Because we have all these perpendicular relationships, the terminator to the equator to the meridians, and the equator to the Earth's axis, the argument concludes that on the equinoxes, the Earth's axis itself must also be perpendicular to the plane of the ecliptic.
Well, hold on a second. That feels like a pretty big leap. How can you go from all those 90-degree angles to claiming the Earth's tilt essentially disappears?
Yeah, it's a pretty mind-bending concept, I'll admit. But the argument hinges on the idea that on the equinoxes, the specific alignment of the Earth and the sun creates a situation where, at least in terms of how the sunlight is hitting the planet, the axis behaves as if it were perpendicular.
So it's not that the tilt literally vanishes,
Right.
but the way the sunlight hits the Earth on those days creates the same effect as if it were perpendicular. But if the axis were truly perpendicular, even for a day, wouldn't there be some pretty crazy consequences?
Oh, yeah, definitely. And that's exactly what we're going to be exploring in part 2 of this deep dive. But for now, let's stick with the logic of this argument for a bit longer, because there's actually another piece of evidence they present, something called the no-wobble phenomenon.
Okay, now you've got me really intrigued. What is this no-wobble evidence, and how does it support this seemingly impossible claim?
So imagine for a second what would happen if the Earth's axis wasn't perpendicular to the plane of the ecliptic on the equinoxes.
Okay, I'm picturing the Earth, tilted on its axis like it always is, orbiting the sun.
Right, and on the equinox, the sun is shining directly on the equator. But if that axis isn't perfectly aligned, the solar terminator, that line between day and night, wouldn't line up perfectly with the meridians either. It would be off just a bit.
So instead of those meridian lines, those lines of longitude all being half in light and half in darkness, it'd be kind of skewed.
Exactly. And that skew, that slight misalignment, would make the equator look like it's wobbling as the Earth rotates.
Like a hula hoop that's not spinning quite right.
Yeah, that's a great way to think about it. But here's the catch. We don't actually see that wobble. Astronomers have measured the position of the equator super carefully, especially on the equinoxes, and it lines up perfectly with the solar terminator.
So there's no wobble evidence. It suggests that at least on the equinoxes, the Earth is acting like its axis IS perpendicular to the plane of the ecliptic.
That's how the argument interprets the evidence, yeah. It's almost like Like the universe is playing a trick on us, making the Earth act like it's tilted differently for those two specific days.
I'm really trying to wrap my head around how that's even possible. It's like saying that for those 2 days, the rules of geometry just change to make this alignment work.
Yeah, it is a real head scratcher. And it really shows you just how much we still don't know about these complex mechanics of the solar system. But let's play pretend for a minute. Let's imagine that the argument is right, that the Earth's axis actually does shift to become perpendicular to the ecliptic on the equinoxes. What do you think would happen?
Well, we talked earlier about how the Earth's tilt is what gives us our seasons. So if the tilt just up and disappeared, even for a day, wouldn't that mean no more seasons?
That's a logical conclusion, yeah. Think about it. A world where every single day is like the equinox. Equal hours of daylight and darkness no matter where you are on the planet.
So no more cozy winter nights by the fire, no more long summer days at the beach. I'm kind of bummed out already.
It's not just about, which season we like best, though. The impact on the planet, on life itself, would be enormous. Entire ecosystems depend on the changes that the seasons bring.
You're right. Plants and animals, they've evolved to thrive in specific climates, to migrate at certain times, to hibernate, to bloom when the days get longer. It's all connected.
Exactly. If we suddenly switched to a seasonless world, it would throw everything way out of whack.
It'd be like hitting the reset button on evolution. Some species might be able to adapt, but a lot of them, probably most of them, would go extinct.
And it wouldn't stop there. Imagine what would happen to agriculture. Growing seasons would be completely disrupted, and that would lead to food shortages, maybe even famine.
Wow, this is getting pretty bleak. Makes you realize just how important the Earth's tilt is to everything.
It definitely does. And it makes you wonder if the Earth's axis shifting, even temporarily, would be so catastrophic. Why is this argument even suggesting it's possible?
Good question. I mean, is this whole thing just a thought experiment, to make us think about the geometry of the solar system? Or is there something more to it?
Well, the source material we're looking at, it doesn't really try to answer that why question. It focuses mostly on the logic and the evidence.
So are we supposed to take this argument at face value?
Yeah.
Could it be that despite everything we see, the Earth's axis actually does this impossible dance twice a year?
That's where things get really, really interesting. Because even though the conclusion itself seems impossible, the logic behind it, it's really compelling.
It's like a puzzle where all the pieces fit together perfectly, but the picture they make doesn't make any sense. Makes you wonder if there's something we're missing, some key piece of information that would make everything click into place.
Exactly. And that's what makes this whole deep dive so interesting. It challenges us to question what we think we know and to consider the possibility that maybe there's more to the universe than we realize.
So where do we go from here? Are we just left with this unsolvable cosmic mystery? Or is there some way to reconcile this impossible argument with what we see happening in the real world?
That's what we'll be getting into in the final part of our deep dive.
All right, everyone, get ready for the grand finale. We're going to try to make sense of this whole cosmic conundrum. We're going to explore the implications of this argument and see if we can find a way to connect all the dots.
Yeah.
Okay, so we've gone down this really deep rabbit hole.
Yeah.
Logic and geometry.
Uh-huh.
And it seems like we've hit a dead end.
Kind of. Yeah.
We've got this conclusion that seems totally impossible.
Yeah. That on the equinoxes, the Earth's axis
has to be
perpendicular to the plane of the ecliptic.
Even though we know.
Right. Even though everything else
it's tilted.
It tells us it's not.
And it has to be tilted to have seasons and
exactly. And yet the logic, like you said, the logic is sound.
The logic, it makes sense.
It all fits.
But it just
it
doesn't work with what we know.
Yeah, it's like, what do we do with this?
I don't know. I mean, part of me wants to just believe it.
Right. Wouldn't it be cool if
because it's
if it were true?
Interesting.
Be like, wow.
Right.
There's the secret.
There's the secret thing the Earth's doing. But then the logical part of me is like, but no.
It can't be.
We've measured this stuff.
Right. We've got the evidence.
Yeah.
And it just contradicts it.
So where does that leave us?
Yes.
What are we supposed to make of all of this?
I think the real takeaway here, it's not about finding the right answer.
Yeah.
It's about how we think about these things.
It's about the process.
The process.
Yeah.
Like asking questions, challenging what we think we know.
Even if it seems crazy.
Exactly. Because that's how we learn. That's how we grow.
So even if we don't figure out this whole equinox mystery, just thinking about it.
Yeah.
Makes us look at the universe a little differently.
Makes us appreciate how much we still don't know.
And that's pretty cool.
It is.
So to wrap things up,
Yeah.
I want to leave everyone with a final thought.
Right.
What if, just what if, this argument is right?
What if?
What if there's something about the Earth, about the equinoxes, that we just haven't figured out yet?
What if we're missing something?
What would that mean?
It's a great question to ponder.
I think so too.
Even if even if we never find the answer.
It makes you think.
Yeah.
So thanks for joining us on this deep dive, everyone.
Yeah, thanks for listening.
We'll be back again soon with another one.
We will. We've got plenty more mysteries to explore.
So until then, keep looking up, keep asking questions, and keep wondering about the universe.